Hi everyone. In this video, we're going to continue graphing parabolas. In this case, we're going to be graphing more general versions of a parabola. So this time, we're going to be graphing parabolas of the form ax squared plus bx plus c. Um, so if we have a parabola of the form ax squared plus bx plus c, the x component of the vertex, that is the point where the parabola turns around, so to speak, the highest or the lowest part, depending on whether or not it opens up. The x component of that vertex is going to be given by x equals negative b over 2a. So let's take a look at this example. Y equals negative 3x squared minus 12x minus 6. Okay, so in order to save time on this, we're actually going to be taking advantage of a few things. First of all, we're going to be taking advantage of the vertex, and we're also going to be taking advantage of symmetry in a parabola. So if you remember correctly, if you can find the vertex, we know there is an axis of symmetry, a line of symmetry that you can draw a vertical line along that. In the previous examples here, you can draw a vertical line like this along uh, the vertex, right? And that's going to give you some symmetry for this parabola. Okay, so here we have in this example, if we want to use this form, x equals negative b over 2a, we can write x is equal to negative 12 over 2 times negative 3. And that's going to give us 12 over negative 6, which is just negative 2 if we simplify that. So the y component of our vertex is going to be given by y equals negative 3 times negative 2 squared minus 12 times negative 2 minus 6, okay? Which we can rewrite that as negative 3 times 4, so that would be negative 12 plus 24 minus 6. That's going to give us just positive 6. So our vertex is given by negative 2, 6. Okay, so we can go to left 2, up 6, and that's going to be our vertex. So we can go ahead and draw that line of symmetry like this, okay? And since that first term, negative 3x squared, since we have a negative number, we know the parabola is going to open down. So all we have to do, really, is pick 2 points to the right of, or to the left, either one, of the vertex, and then we can take advantage of the symmetry, and we can get a pretty good idea for our general shape, okay? So let's try maybe 1 point to the right. So let's try x equals negative 1. So we'll have negative 3 times negative 1 squared minus 12 times negative 1 minus 6. Okay, so this is going to give us, looks like a negative 1 squared is just 1. So we'll have negative 3 plus 12 minus 6. Okay, so that's going to give us 3. So we're going to have the point negative 1, 3. So we'll go to the left 1 and we'll go up 3. Okay, and remember, since we have this symmetry here, we can go ahead and just go directly across and know that we have this point here as well. Okay, so we're going to get both of these points for free, or at least one of these points we're going to get for free because we have access to that symmetry. So let's try x equals 0, and we'll have negative 3 times 0 squared minus 12 times 0 minus 6. Well, 0 squared is just 0, and anything times 0 is 0. So this is just going to give us negative 6. Okay, so we have the point 0, negative 6. Okay, so it's going to go here, and we know we're also going to get this point as well for free just by the symmetry. So our basic shape of our graph is going to look a little bit something like this. Okay, let's try another one. Here we have y equals negative 2x squared plus 16x minus 27. Okay, so for this one, if we use x equals negative b over 2a for the x component of our vertex, we'll get x equals negative b, which is negative 16, over 2 times negative 2. So we're going to get negative 16 over 4, or negative 4, sorry, which is just going to be positive 4. Okay, so we'll have y equals negative 2 times 4 squared plus 16 times 4 minus 27. Okay, 4 squared is 16. So we'll have negative 32 plus 16 times 4 minus 27. That's going to give us 5. So we're going to have the point 4, 5 for our vertex. So x component is 4, y component is 5. So we can go to the right 4, and we can go up 5, and that's going to be our vertex. And again, because that first term is negative, we know that it's going to open down, so we should have enough space on the graph. Okay, so let's do 1 point to the left. So we'll have maybe let's try x equals, I don't know, 3. So I have negative 2 times 3 squared plus 16 times 3 minus 27. Okay, so that's negative 18 plus 16 times 3, and then minus 27 is going to give us 3. So we have the point 3, 3. 2, 3, 1, 2, 3. So this is our next point here. And because of our symmetry that we can draw right here, we also know that we're going to get this point for free as well. Okay, let's try x equals 2. So if x equals 2, that's going to give us negative 2 times 2 squared plus 16 times 2 minus 27. Okay, so that's negative 2 times 4, which is negative 8. And we'll have plus 32, and then minus 27 is going to give us negative 3. So we'll have the point 2, negative 3. 2, negative 3. And again, we can take advantage of this symmetry, okay, and we get this point for free. So this is going to be the general shape of our graph.